convex lens. So obviously the two glass spheres, they're combined, and the common part will be the biconvex. And if radius of curvature of both the sphere, if it is equal, I mean, if R1 is equal to R2, then the biconvex lens, it is also called as equiconvex lens. And this is, it is made up of single sphere, right? So only this much part is taken out. So this is plano-convex lens. And here you're going to have two spheres. One is bigger, another is smaller. This part will be concavo-convex lens. And the second type, it will be concave lens. So again, two spheres. This is going to be the region where the lens will be formed. So this is plano-convex lens. Sorry, not plano-convex lens. It is biconvex concave lens. Here also, if the radius, if R1 is equal to R2, the radius of this and radius of this is, if it is equal, then it is called equiconcave
Concave lens.
lens. So now you got one sphere and this part will be taken. So it is plano convex lens, not convex, concave lens. And at last, you're going to have two spheres. One is small, another is going to be big with the center C1 and C2. Now this part will be taken. So definitely it will be convexo-concave lens. So in total, there will be six types: biconvex, plano-convex, concavo-convex, then biconcave, plano-concave, and convexo-concave. But is it clear?
Yes.
Yes.
Fine, write it down.
Done, sir.
Okay. What about others?
No,
Done, sir.
no.
I think it is done.
Yes.
No, sir.
Okay, fine. So everybody finished?
No. Done.
Okay. Now, next is primary and secondary focus of a lens. Primary and secondary focus of a lens. So first we will consider convex lens, convex lens. So this will be the convex lens. Suppose you have got a point source. You have got a point source. So I'll take this to be P, and P refers to point source. Right? And it is placed at the focus of the lens on that side. Right? So it is placed here. So I'll take this to be F1. So rays will come out of the source. Since it is in focus, all these rays, they move parallel to the principal axis. Right, Bacha?
Yes.
Yes.
So if the rays are moving parallel to the principal axis, it means this point source, it is placed at primary focus. This point will be called as primary focus. This is first, primary. Now we will talk about secondary. Same situation. You got a lens, and this is optical center. Now, bacha, you're going to incident the parallel rays. So if parallel rays are incident, quite obvious, they will bend and they will intersect at
Focus.
the focus on the other side. Right? And this focus, I'll take it as F2. Right? And this will be called as, it is called secondary focus. I hope it is very clear. So from here to here, obviously this distance will be, I can take F1 here also. So this distance will be F1 from the optical center. Again, this distance from here to here, it will be taken as F2. Okay, is the diagram clear?
Yes.
Yes.
Now what happens, Bacha? For thin lens, if the lens is thin, then F1 and F2 it is going to be same. That you have to keep it in mind. So for thin lens, what you're going to have, F1 will be equal to what, Bacha? F2.
F2.
Clear up to this part?
Yes.
Yes.
Okay. Now we will do it for concave lens. So the similar situation. So we'll place the concave lens here. So rays are incident in this manner. So if they're incident in this manner, we all know it moves parallel to the principal axis, right?
Yes.
So if they move parallel, then obviously they will intersect maybe at this point.
Focus.
Yes. Focus.
Exactly. So this will be the focus. And this will be taken as F1, and this will be the primary focus. of this lens. And again the distance, it is going to be f1. So similarly, if you got parallel rays which are intersect, if it is incident on this lens, maybe like this. So you know that they're going to deviate like this, right? So we get point somewhere here. Right, bacha?
Yes.
Yes.
This is F2.
Secondary
this will-
focus.
Secondary focus. Again, the distance from here to here, it is F2. And here also for thin lens, you're going to have same equation. That is F1 is equal to F2. I hope everybody followed up to this much.
Yes.
Yes.
Next, you're going to have refraction of standard ray through thin lens. It can be convex, it can be concave. So refraction of standard rays through thin lens. But the standard ray means we are going to study the rules of all three. I mean convex and concave lens. Means if ray is parallel to the principal axis, what will happen? If it is passing through optical center, what will happen? If it passes through focus, what will happen? All these things, right? So, in short, if you got a convex lens, this is optical center. O, you know this is F1 and you know this is F2. Right, bacha?
Yes.
If ray is parallel to the principal axis, we all know it will pass through F2, right? Right, bacha?
Yes.
Yes.
So F1, F2. If it passes to the optical center, you know that it goes
Undeviated.
undeviated, right? And third case, so this is O, this is F1, this is F2. Now it passes through the focus like this,
Parallel.
Parallel to principal axis.
parallel to principal. These are the three rules. And these are the standard rays. I hope it is very clear.
Yes.
Similarly, this is for convex. Right, bacha? Now for concave lens. So again, I will draw all the three cases here. Fine. But here also, you're going to have F1 and F2. Now tell me, in first case, obviously you're going to have a parallel ray, right? Same as this. So it moves in this manner, and as if it is, it is coming from F1. Right, bacha?
Yes.
Yes.
Okay, next case, if it is passes through the optical center, you know that it goes
Undeviated.
undeviated like this. And at last, when it passes through the focus, maybe like this. Right? So what it will do now? Yeah, if it moves
Parallel.
like this, it moves like this. Suppose if it is incident at, maybe in this manner, like this. You getting me?
Yes.
Yes.
parallel. Clear up to this much? Any doubts?
No, sir.
Okay, complete this. Bacha finished?
No, sir. Done, sir.
It's all finished?
Yes, sir.
Okay, fine. So next we will get into image formation. Fine. So when it comes to image formation, definitely first we'll take convex lens. Image formation. For convex lens. So you got a convex lens. This is F. This is 2F. Similarly, this is F and this is 2F. If you want, you can write F1, F2 also. So because for thin, it will be the same. So first, I will keep the object at infinity. I mean, U is equal to infinity. So obviously, we should be at F.
F.
So yes, object at infinity. Object at infinity. Right? So you're going to have parallel lines like this.
Parallel.
So they will converge at F. So definitely you're going to have the point image. Right, Bacha?
Yes.
Yes.
So it is highly diminished. Highly diminished. This is first case. In second case, we'll bring the object, of course, in between infinity and 2f. So u will be less less than infinity, more than 2f. Is it clear, Bacha?
Yes.
Yes.
So obviously the image will be formed in between f and
Between
2f.
F
F
and
and
2F.
2F.
Yes, greater than f and less than 2f.
Lesser than 2F.
Right. So you're going to have the convex lens. We should little this side. So this is F, this is 2F, this is F, and this is 2F. So you're going to place object here. Right, but this is optical center. So the ray parallel to the principal axis will pass through the focus.
Focus.
Right? And obviously the ray which will pass through the optical cell, it goes undeviated. So it is going to intersect between F and the 2F. So definitely you're going to have a image. Clear up to this part? So the real
Yes.
refracted ray will intersect. Therefore, the image formed will be real.
Real image.
So you're going to have real image. Definitely the size. If you compare the size, it will be less
Small.
than the object.
Lesser than.
Less.
Yes. So I would say M is
Lesser than 1.
right, less than 1. Is it clear up to this part?
Yes.
Yes.
Okay. So next case, you will bring little further, you will keep it as 2F. So U is equal to 2F. V will be as 2F.
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 Right. So this is F, this is 2F. The object is placed here. This is F and this is 2F. This is optical center. So obviously it will pass like this. And this will be passed. So this is how it is going to be. Right? So here also the image will be real
Real image.
and M
Same
will be
size.
equal
Same
to
size.
1.
Magnification equal to 1.
1.
exactly, it will be equal to 1. But clear up to this part? Any confusion? You will bring in between F and 2F. So U is equal to. Obviously, it will be greater than F and less than. Here it is going to be, right? So it will be less than 2F. Right?
Yes.
Yes.
Now U will be
Greater
than
than
infinity.
Greater than
2F.
2F.
Less than infinity.
Right. So now it is going to be this is F, 2F, O, F, and this is 2F. Now it is going to be somewhere here. This will pass like this. So this will move here. So real image,
Magnified.
exactly, it is magnified. So M is
Greater
greater
than 1.
than
Greater than
1.
1.
right. Fifth one. So now you move further, you will keep it at F now.
Infinity.
Infinity.
Exactly. So B will be infinity. So it is F, 2F, F, 2F. So object is placed here. So obviously this will move like this. This is O. This will move like this. So it will be at infinity. Right, bacha?
Yes.
Yes.
So infinity. Okay, fine. So sixth one. Sixth one, you will be keep it between O and F.
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 Means U is greater than 0, less than F. Right, bacha?
Yes.
Yes.
So what will be the value of V?
Same side.
It will be
Beyond
greater
F.
than V. right?
Yes.
Yes.
Okay, fine. So this is F, this is 2F. This is O, F, and this is 2F. So placed here. So obvious it will intersect at this point and it will move in this manner. So I can extend this line. So you're
Virtual
also
image.
saying things.
Virtual image.
Highly
magnified.
You're going to have virtual image with the M
Greater than
1.
1.
But clear up to this much, any confusion?
Yes.
So I think if you're done with mirror, then obviously it is similar type, right?
Yes.
Yes.
Okay, finish this, bacha. Complete this.
सर थोड़ा ब्लर हो
Just a second. Finished?
No, sir.
No, sir.
Finished?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So we'll move towards concave lens now. Next is concave lens. So in first case, obviously, here we are going to have only two cases. So first case will keep object at infinity. So if object is at infinity, so we'll have parallel rays. So we should be at F,
Focus.
right? So this is O. So object at infinity. So you're going to have parallel rays. So this is F, this is 2F, F and 2F. Now you all know it is a diverging lens. So will deviate in such a manner. It appears to coming from focus. Right, bacha?
Yes.
Yes.
So here you're going to have image. So image will be formed definitely at focus. Yeah, if they're not parallel, it will be produced at focal plane. Yes or no?
Yes.
Yes.
So you can imagine a plane here, right? Maybe like this. So image is formed at focal plane. Focal plane will take care of focus also. And the image will be virtual because they don't actually intersect. It appears to intersect, right?
Point image.
Yes.
Exactly. So you're going to have point image, yeah, size. So this will be the situation when it is at infinity. Now, anywhere in between 0 to infinity. So we'll keep u great, it is less than infinity and greater than 0. Anywhere, right, bacha? So v will be
Between O and
greater
F.
than 0. Exactly.
Less
So this
than F.
O and F. Right. True. So this is the principal axis. This is O, F to F, F to F. So I'll keep it at this point. So the parallel ray, we all know it goes
Passes through focus.
right. It will move like this. But the ray which moves to the center, that is optical center, it goes undeviated, right? So here they are going to intersect,
Yes.
right, bacha? So here you're going to have image. So this will be the image and this is going to be the object. Now, definitely I is produced, image is produced in between. Where, bacha?
F and O.
F
And
and
O,
O.
right? And it will be
Image.
virtual,
Less than 1.
M is less than
virtual,
1.
M is less than
and
1. Diminished.
it will be diminished, right?
Erect.
Where F will be less than 1. Ah, you know that if it is virtual, it has to be erect. Yes or
Yes,
no? Real
yes.
image
Yes.
are inverted. Clear up to this much, bacha?
Yes.
Yes.
Complete this. So you're done with the image formation of both the lens, convex as well as concave.
स्क्रीन क्लियर है.
But the screen is proper. Bacha, what about other students? Can you see it properly?
Yes.
Yes.
Okay.
Done, sir.
Okay. Fine. So, bacha, up to this much it is clear?
Yes.
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 Fine. So next time we will deal with how to find focal length of convex and concave lens by means of lens maker formula. You know lens maker formula, right?
Yes.
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 I mean, we will discuss what will be the focal length when it is biconvex, plano-convex, concavo-convex, like that. We will do it for all the 6 cases. But for that, you should know what is the formula for, what is lens formula. That equation you should know,
सर
right?
लेंस मेकर और फोकस का फॉर्मूला.
तो लेंस मेकर में ही फोकस का फॉर्मूला आता है ना,
हाँ हाँ यस हाँ.
अलवा. What are you going to do? Then we will convert that, that formula, radius of curvature is there now, so that will be converted into, what will be the radius of curvature for plane. Plane means definitely R will be infinity, like that.
Infinity.
Right? So we'll change the formula according to the lens. So you'll have formula for all the three lens. So 3 plus 3, it will become 6 cases. You got it?
Yes.
Yes.
Fine. So that we will do it next time. So I hope up to this much it is very clear. So we'll stop now. We'll continue next time.